Okay, today we're going to do exercise 5.2 question 13. If you look at the entire question, actually the whole question mainly is about using of general term to find certain terms inside the binomial expansion. So first, right, they want the term in x to the power of 10. So before I even do x to the power of 10, what I do here is this: I find the general term for the expansion. So first, general term is given to me by 10 choose r, okay, a to the power of 10 minus r, okay, then b, which is negative 2 over x squared to the power of r. That is the general term. So if you want to expand this, okay, or you want to simplify this, what we get here is this. If I open the brackets here, 3 times 10 minus r will give me x to the power of 30 minus 3r. Okay, for here, I'll rewrite it as negative 2, right, times x to the power of negative 2. This x squared, a to the power of m, a to the power of negative m is 1 over a to the power of m. So I write it as x to the power of negative 2 in negative index form. Okay, and we have r in this case. Simplifying further, what I get is x to the power of 30 minus 3r, negative 2 to the power of r, x to the power of negative 2r. Okay, if we remember from our laws of indices, a to the power of m times a to the power of n is a to the power of m plus n. So in this case, if I simplify everything, 10 to the power of r, negative 2 to the power of r, and here I'll get x to the power of 30 minus 3r minus 2r. I simplify further, negative 2 to the power of r, and here will be x to the power of 30 minus 5r. Okay, notice that this is a term in x. 10 to the power of r is a number, negative 2 to the power of r is a number. So in later on for the question, this portion here will actually give me the coefficient of whatever term in x we're trying to find. Okay, now for 13 part 1, right, they want the term for the term in x to the power of 10. Okay, so x to the power of 10, so I say x to the power of 30 minus 5r equals to x to the power of 10. The whole point of this is I'm trying to find what value of r will give me x to the power of 10. So I compare coefficients. 30 minus 5r equals to 10. Alright, we solve. Negative 20. My r is equals to 4. So if I put it back, right, my term in x to the power of 10 will be equals to 10 choose 4, negative 2 to the power of 4, then x to the power of 30 minus 5 times 4. Okay, if we work everything out down here, this times this will give me 3360 x to the power of 30. Okay, 30 minus 20 x to the power of 10. Everything works out fine, and we will have the term in x to the power of 10. Now I move on to 13 part 2. For 13 part 2, the coefficient of 1 over x to the power of 5. Okay, for 1 over x to the power of 5, I can rewrite it as x to the power of negative 5. I write it as a negative index. Then you ask, why in the world would I want to do that? Because I'm going to do something similar to what we did above down here. For this, I'm going to write x to the power of 30 minus 5r is equals to x to the power of negative 5. Then I start to compare my coefficients. 30 minus 5r equals to negative 5. you solve for r is equals to 7. So basically, right, for the r value of 7, I can find when I sub in r equals to 7, okay, into here, 30 minus 5 times 7 is 30 minus 35. It will give me a negative 5. So if r is 7, I'll get a term where I'll get 1 over x to the power of 5. I'll get a term with x to the power of negative 5 inside. So that's the whole idea behind this. Then what we do here is this: they want the coefficient. So the coefficient of the term, coefficient of 1 over x to the power of 5 is, just now as we have discussed earlier, the coefficient will be 10 choose r negative 2 to the power of r. So in this case, what we have is 10 choose 7 negative 2 to the power of 7. You just key all of it into the calculator and you get negative 15,360. Okay, quickly I move on to 13 part 3. Let me adjust the camera here. Okay, 13 part 3. 13 part 3 will ask us to find the constant term. For constant term, okay, constant term basically means that we are actually looking for x to the power of 0. Because x to the power of 0 will give me a x to the power of 0 is 1. So it just gives me a term, a constant term with numbers without any variable like x inside. So similar to the examples we have done above, I write x to the power of 30 minus 5r equals to x to the power of 0. You start to compare coefficients. 30 minus 5r is equal to 0. R is equals to 6. Basically, right, for r equals to 6, you will get a term with x to the power of 0. Don't believe? Let's try it, okay? T, r plus 1, 6 plus 1, okay, is equals to, okay, where is my previous term? Okay, my previous term is 10 choose r, 10 choose 6, okay, negative 2 to the power of 6. X to the power of 30 minus 5r, 30 minus 5 times 6. Then if you key everything into your calculator, you will get 13440. X to the power of 30 minus 30 is x to the power of 0. So you get a constant term where the constant term is simply 13440. And that concludes this concludes question 13. And I think question 13 is quite a good question for us to illustrate the use of the constant term.